Okay, geometry topic 4 review on triangle congruence, right? So this was a main concept in this class about congruence. So first of all, the rigid motions that we used in topic 3, so reflections, translations, and rotations, they all result in congruent figures, right? They're called congruence transformations. So when you have congruent figures here, you know that all the corresponding angles are congruent. So in these two triangles, P, Q, R, and P prime, Q prime, R prime, angle P and P prime are congruent, angle Q and Q prime are congruent, angle R and R prime are congruent. You also know that the three side lengths are congruent. So segment PQ and segment P prime, Q prime are congruent, segment QR and segment Q prime, R prime are congruent, and segment PR and segment P prime, R prime are congruent. Okay, so now the next lesson in topic 4 was on isosceles and equilateral triangles. So these are special types of triangles. So before we get into the congruence part, so isosceles triangles could be seen. So remember, an isosceles triangle has two congruent sides, it has two congruent angles, right? Now this perpendicular bisector rule, if I drop from, so this B angle B is called a vertex angle. So it's the angle that hinges the two congruent sides. It's not one of the congruent angles. If you draw a perpendicular down from it, right, it's going to do two things. It's going to bisect this bottom side, so A to that middle is going to be equal to C to that middle, and it's going to bisect angle B at the top. So you can see there's a lot of good, it's hard to see because of my drawing, but there's a lot of good relationships here in isosceles triangles. In equilateral triangles, you have three congruent sides and three congruent angles. So remember, this is your regular triangle, right, regular figure. Because you know the three angles are congruent, if you do 180 divided by 3, you know that each angle is 60 degrees. Right? So you might see those. All right, but the more important idea from topic 4 is your types of triangle congruence. Side angle side, 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 side. So side angle side. Two sides and the included angle. Right? The angle in between the sides. Side, 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 all three sides. Not a big deal there. And then you have the last two involving angles and sides, angle, side, angle, 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 side. Very similar here. This one includes two angles and the included side. This one here involves two angles and a non-included side. Now, there is this thing called the third angles theorem, which says that if you know two angles are congruent, you also know the third angles are congruent. And again, it's because the three angles add up to 180 in a triangle. So you actually know that if these two angles are congruent, then angle L and angle R are also congruent here. So you could use angle, angle, side, or angle, side, angle. Same thing here. If you know angles U and V are congruent to X and Y, you also know that angle W is congruent to angle Z. And you could use angle, angle, side, or angle, side, angle. Right? So there's very much a relationship between those two. And then last but not least, in your right triangles, right, there's a special, now you can of course use the other side, 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 angle, side, but there's a special one called hypotenuse leg. So if you know the hypotenuse are congruent and a pair of legs are congruent, and that they're right triangles, then you can use HL. Now this would technically be side, side, angle, which is not one of the ways. This is not a way. But because it's a right angle, we allow it and call it HL. Okay. Now the last thing to remember about these, you don't need lesson 4.6 to know about. The last thing to remember is CP/CTC, right? So typically, if you have to prove, say you have to prove that a pair of angles are congruent between the two figures, or a pair of sides, you have to prove the triangle is congruent using one of these 5 ways, and then your next step is typically CP/CTC, corresponding parts of congruent triangles are congruent, right? And that is just saying that once you've proven the triangles are congruent based off the three pieces of information you need, then the other 3 that you haven't really talked about are also congruent. Okay, and again, this is going to be seen in proofs. All right, and there's topic 4.